Good morning and good afternoon, and welcome to our conversation on densification. This is for a report by Sensafili in collaboration with RCR Wireless News. Today, I have the pleasure to talk with Nivi Thadasina. He is a Senior Director of 3G, 4G, and 5G, and the Wireless Network Systems Division at Samsung Electronics. Nivi, thanks for being with us today.
Thank you for this opportunity to talk to us.
Okay, so can you tell us to start, what is the Samsung is doing in the area of densification, and what is your personal involvement within that?
Okay, so I've been with Samsung for over 10 years, and I've been involved with small cells since 2014, even before the term small cells was introduced. We did the initial research. Part of the reason why we did the initial research was based on Samsung's capabilities. We make end-to-end products, as you're aware. Not only that, we have the capabilities to manufacture our own chipsets. So with that in mind, we said, okay, hey, what is the best way to go address a need within the United States? And as part of that is how we started to look into these small miniature base stations, even before the terminology small cells was introduced. And that eventually led to our world's first small cells. At that time, we were calling it femtocell, launch with Sprint. That was back in 2007. What I do for Samsung is that I take care of the products. I do the requirements, product definition. Then the product is developed within our headquarters. And then I do the validation, and then I do a commercial rollout of small cells for both for residential as well as enterprise for the United States.
And you know, as I said, Samsung has been involved in small cells for a long time. I remember the 2007, the Sprint launch, and and interestingly, a lot has changed in this year. So we're still at the beginning, but still a lot has changed. Can you tell us how you see the change throughout this, you know, I guess the first decade of small cells?
Right. So, I mean, small cells, I mean, back in 2007, right? Let me start out from 2007 when we were the first to launch it. At that time, the need was coverage, right? In building was a challenge, and the signal was not penetrating where it needs to. So the immediate need from our customers was, hey, can we get coverage in areas where it's very hard to reach through macro cells? So coverage was the initial need. That eventually led to, hey, now that we got the coverage, we are able to address coverage. Can we also look at capacity offload, especially users who are on the cell edge of macro, because they are the ones who consume most power and resources from a macro standpoint. So they were looking at, okay, can we use this product tool to see, can we also do a capacity offload? So that was all part of the 3G. And then eventually, now as we looking at evolution from 3G to 4G, now the biggest need we see is voice over LTE, okay? Can I get coverage in areas which is very hard to reach? And so as part of that is our customers are looking at small cells as, hey, can I use this tool to address VoLTE coverage? With that, obviously, we'll get a better user experience. Not only can you get better user experience, but also now all of a sudden the customers are looking at is that with better user experience, but also you're getting a better improvement in spectral efficiency. All of a sudden now in the outdoor network, the macro cells, I'm able to squeeze more bits per hertz now that you're able to take those tough users who are on the cell edge are able to offload it to the small cells. And all of that spectral efficiencies and so on, eventually now that can lead to 5G. As you're aware, 5G is the next evolutionary steps. And millimeter wave is an area which is can be have a very large path loss. Propagation characteristics are tough. And so I would say that the 5G is a very natural evolution where the small cells probably you'll start to see.
Right, and so two things. It's the increase in spectral efficiency, and I wanted to ask you about it, and the new bands with 5G. So with respect to the increased spectral efficiency in 4G, what we're saying is interesting because what you're seeing is an increase in spectral efficiency in the macro. So the small cells not only improve the local performance of the people inside the buildings who are closer to the small cell, but also seem to improve the macro. Is that correct? So small cells help the macro as well. Because usually in the beginning we thought you just put a small cell for the people using the small cell, but it's actually maybe benefits even more the people that are at the edge of the macro.
Yeah, absolutely. I mean, because you would see various different comments from the operators in terms of how they're able to, by virtue of addressing those tough customers who are deep inside a building or on the cell edge, how an average sector throughputs of a macro cells have increased, right? That's mostly because of the fact that now all of a sudden you're able to get better MCS rates, better bits per hertz. You're able to go address it. So definitely, I think it's a win and win for both.
Yeah. Now, in terms of indoor, you mentioned the tough customers inside the buildings. In terms of the location of the small cells, do you see a shift between indoor and outdoor locations? Is there more of an emphasis on outdoor locations or indoor locations as we move forward?
I think if you were to look at Samsung, right? I mean, and it's Samsung has been. I mean, we've been focused on indoor. I think for a couple of different reasons. Is that there is already well-published statistics in terms of what percentage of calls. I mean, the number is anywhere from 50% to 70% of the calls originate from deep inside the building. There are also numbers in terms of is how much of the indoor spectrum is fully utilized by the operators. And you see a wide range of numbers where the outdoor spectrum is utilized, but not necessarily in indoor. Mm-hmm. But now, if you look at this too, is majority of the calls are originated from indoor, plus significant portion of operators, the most high-valued assets, which is the spectrum, is underutilized in indoor. With that by having a small cell deep inside a building, now all of a sudden the operators are able to go address it. So from Samsung's standpoint, we see this as a great opportunity, not only because of the fact that we're able to go address and relieve a macro network, and thus reducing the capacity demands on the macro network to address those users deep inside a building. Plus, we are able to go address the voice or LTE challenges operators face, and which are typically in indoor locations.
Right. And the operators do not want to just use Wi-Fi calling?
So, okay, a very good question. And there's different opinions on that, right? So from an operator standpoint, let's take yourself an example. You make voice over Wi-Fi calling, and let's say you come across voice quality challenges or call drops, or as in when you're transitioning between networks, you're not able to cleanly transition. Now, when that happens, is you're using a cell phone from an operator, and when you call the operator to address your concerns, operator is not able to see the user experience from your standpoint, because all that particular call is not handled by a network which is outside of their domain. So one way of addressing would be is that if I can pull that call from a Wi-Fi to voice or LTE, all of a sudden I can now able to go see and predict the user experience And so that's one thing. And the second is that it's well publicized that with the Wi-Fi, the coverage within your homes is still somewhat restricted compared to coverage you can experience with the small cells. We have heard a lot of comments coming from the field where as soon as they install the small cells, now they're able to go make that call from the backyard or somewhere within their yards where they could not do so before with a Wi-Fi.
Yeah. Okay, so now back to the 5G proposition. That's a huge opportunity there because you're going to have different bands. At Samsung, how do you see those new bands, which are traditional? Some of them are traditionally not cellular bands, like millimeter waves. How do you see them being used for densification purposes?
So right now, I mean, you saw the FCC ruling that came out recently. They're looking at immediately looking at 4 bands, right? So it's a great news for all of us. The 28, 37, 39, and the 60 gigahertz. So right now we're doing a lot of work in 5G in this area, and we've been looking at 5G for the last several years. So from our standpoint, I mean, we see a great opportunity. There's an immediate opportunity in 28 gigahertz. As part of that, we are looking at multiple different solutions, not only outdoor, but also indoor. So what we think here is that by virtue of Samsung's strong presence in small cells, we see a distinct advantage for Samsung in terms of how we can go address 5G coverage and capacity based on our knowledge.
Mm-hmm. And so what kind of bands do you see that are better suited for indoors or versus outdoors? There is a lot of debates of, yes, we have all the spectrum, but what's the best way? Is it backhaul, access? What's the best way to leverage it?
Which one, within the millimeter wave, or are you looking at the whole
millimeter waves and the other sort of basically millimeter waves versus other bands like 3.5.
Right. So I think so what we think is going to happen is that I think you'll see our customers deploy all the way from sub 1 gigahertz, namely 600 megahertz, all the way to millimeter wave. And so I think is that it's already well known that once you reach millimeter wave, the in-building penetration can be a challenge, right? So we think that you would need a solution, a combination of able to go address it from outside in as well as within inside solutions. You will see 5G deployments not only vary from 28 gigahertz, 37, 39, but also in 60 gigahertz. 60 gigahertz, of course, can be far more challenging relative to 28 gigahertz. So I think there, plus the fact that 60 gigahertz is an unlicensed spectrum, you'll see a combination of how the 60 gigahertz might be utilized. It could be used very similar to how, for instance, the 5.8 and 2.4 Wi-Fi coverage use cases, plus also use it as a channelized backhaul solutions.
Right, and there is sort of there are 2 different views that you can take, well, and everything in between, I guess. So as you move higher in frequency, the range is shorter, obviously. And so that can be an advantage in indoor locations because you have less interference, but on the other hand, you need more equipment because the range is smaller. What's your view on this? What are the trade-offs?
So the views in terms of how you would go address it, or in terms of how you would go deploy?
Both. I mean, what do you do in terms of deployment? Is it useful if you have a cell that the range is so short that you need so many of them? At the end, is it cost effective for an operator? Or how could it be cost effective for an operator given that the range is so short, so small? Right.
So very similar to how small cells are being done. I think density will become a huge factor. And there are some solutions, I mean, we are looking at where can we extend the range of 5G in millimeter waves well beyond what the industry has been looking at, okay? Can we reach the cellular levels, right? So it's not there yet. So the beam formation, adaptive beam formation, how much gains can you get, how narrow the beam can be. I think some of these technologies and techniques can be utilized to overcome and the path loss, right? So we do believe that the technology for 5G is ready. We have done a lot of trials to demonstrate how we can close the link at much further distance than initially assumed. Not only in terms of able to penetrate through walls, through windows, as well as through foliage, vegetation, leaves, all these things can certainly be a challenge. But adaptive beam forming is a technology that's part of our solution, which will help a customer able to close the link at much further distance than you would. Yes, I mean, if you were to compare cellular and sub 2 gigahertz footprint versus a 5G footprint, I think we do believe that the 5G footprint would be much shorter than a typical cellular, right? So that's the reason why I think is you would see solutions where it would be a combination of using street furnitures, using various different buildings and tower tops, a combination of these three.
Right, and then so there is going to be many more types of solutions out there. Now that brings the issue that not only you have different solutions, different locations, but also different vendors. How do you view that? Because this has been a challenge for a lot of operators. They want to have equipment from different vendors, but integration sometimes is not easy. What's your view on this?
Yes, and so when we approached small cells, right? I think we encountered the same challenges not only with 3G but also 4G. So when we designed our products, we designed our products day one to underlay a macro network, right? So there are incumbent vendors. They already have a well-established. Now the question is how can you coexist? And not only I can coexist, but at the same time is from an end user standpoint, the end user should not know the difference that, hey, I'm on a Samsung network or someone else's network. The handset should seamlessly move between these multi-vendor solutions. So there are certain things that we have done to our product to seamlessly coexist. And on top of that, the coexistence will come in two forms. One is that how can you coexist from a radio standpoint, and how can you coexist from a core network standpoint? So there are different solutions to address the radio as well as from the core network standpoint. So let's talk about core network as for instance. Is that the 3GPP has done a very good job in terms of standardization of the S1 MMEs and S1Us. And not only Samsung but also other vendors were able to successfully interop between an eNode B from one vendor to MME from another vendor. Plus the 3GPP has done, as I said, has done a very good job in terms of coming up with a well-defined interface specifications, which makes it very easy for multi-vendors to interop. Yes, there are certain things the operators can still do, especially in the X2 area. Anytime two different radios from two different vendors needs to interop in a seamless manner. There are certain things I think the operators can do to enhance that and facilitate interop between these vendors. Another area I would say is SON, right? It's not necessary to have a vendor agnostic SON, but certainly having that would help promote a truly multi-vendor radio network.
Right. Now, to add that to that, in terms of having different vendors, there's also different technologies. So we have LTE, and operators are using more and more Wi-Fi along it, and then also LTE unlicensed, LTU or LAA, LWA, multifier, all sorts of things. So there is another level of integrating performance across different access channels. What are you doing there, and how do you see that this field developing?
Yeah, very good question. I mean, yes, I mean, you're right. I mean, I think the technology is getting more and more complicated. Not only you're looking at all the different multiple bands, multiple technologies. Now you're looking at combination of LTE and the Wi-Fi's and so on. So certainly, I think the way we envision this is that I think expect probably there might be like 3 or 4 different flavors of this technology. I think you might see a combination of LTE and Wi-Fi, since Wi-Fi is prevalent. So you might see a LWA solutions out there. LTU is something that we are aggressively pursuing, and certainly I think you'll see that plus LAA. Of course, multifier is also out there, and each of the solutions have its own pros and cons. But eventually, I think this industry will evolve and hopefully will converge.
Mm-hmm. Right. In closing, let me ask you what is it? Are you working on Samsung today in preparation for the next, say, 5 years? What is the focus for the future with respect to densification?
Right. Yes, I think there's a lot of exciting things Samsung is working on in terms of how we can capitalize on our experience from and lessons learned from 2G, 3G, and 4G into 5G. Plus, as an industry, I think there is a rapid evolution from a physical elements to virtualization. So that's another which is happening. So Samsung is clearly looking at all these different opportunities, technology evolutions, talking to various different customers, not only in the US, worldwide, in terms of how best we can design our solutions to fit their needs. One of the biggest strengths Samsung has is that not only we can provide end-to-end solutions, but also we can develop our own chipsets. Certainly that plays a strong role in terms of how we can impact the evolution path for our customers.
Right. And so you have your own chipset, and you mentioned virtualization. Does it mean also that you're working on the CRAN part of the solution for small cells?
Well, I mean, yeah, the CRAN solution. I mean, we have launched CRAN in Korea. I think that's already well published, and so I think is when I talk about virtualization, I think the virtualization probably will looking at various different split of how different layers within eNode would be split, right? And if you look at a small cell, a small cell is essentially the complete eNode B in one box, right? So with the Ethernet backhaul. As we evolve towards 5G, I think what makes sense is a combination of from that where we have all the layers stacked in one box to a combination of having a radio plus everything else perhaps would be virtualized.
Yeah. Okay. Well, Nivi, thank you so much for sharing your thoughts with us today.
Thank you for giving us this opportunity.
Okay, well, thanks to all of you for listening in. This was a conversation that is part of a report on densification by Sensafili in collaboration with RCR Wireless News. Thanks again.